All right. So you guys help me out. When we set these classes up, one thing is that's really tricky is this class, your brain says it's 8y, but you know it's not. So I always start off with put the lowest data point and then add the class width to get this guy, and it tells you what's got to go there. Is that cool? So this has got to be 9 apart. So on your homework and stuff, you'll see me, sometimes I'll go 8, and I'll have an arrow drawn. You said 9, but you used 8. I don't understand. Or there'll be a 10 here, more likely. All right. So here we got our 9. So if I count from 9 to 17, I think the first one that falls in there is 10. Up to 15, if I remember correctly. Just count the number of data points that actually falls in there. And how many fall in there?
That one's
6. And then 18 to 26 goes back up to 12. Yeah, 5 people work in between here, and 4 people work within those hours. Cool. All right. Did people get close to that or that exactly, or do you understand where those would come from? It's kind of weird when you first do these, you're not really sure what the hell you're counting to get these numbers. You're just counting how many data points fall in here. So then you can see, where do people work the most? Or what's the highest percentage of, between what hours are the highest percentage working? Okay, it looks to be 2 types that are equally tied. Now here, this one I did for a couple reasons. One is I knew it was going to come out, because the highest person was 45, the lowest is 0. So I knew it was going to come out to be an exact whole number. So we had that freaky thing down here, where there should be a 44, but you're allowed to make it 45 just to suck that last data point in. So that's one thing I want you to realize. Okay, good. The second thing is, it's a 0 here. So what's halfway below it? Negative 0.5. And normally the way we kind of do that is just to kind of move it over here. This won't be 0 then. So just don't label that piece. You doing okay? What's the matter?
Why did you put 0? Or why did you put 0.5? Not just 0.
I can't use just 0 because if I were to do that, I definitely don't want to see this. It's not labels. I'm not labeling my classes. It's an actual scale. They're true numbers. So I should be able to use a true scale, and I can't have any gaps here. To make it not have gaps, I say, okay, this actually goes from -0.5 up to 8.5. And it would still capture the same number if I did that, wouldn't it? So the only reason I do that is because, so this goes from -0.5 to 8.5. This goes from 8.5 17.5, so forth. So now these fall right on top of each other. There won't be any gaps. Now again, if we were using a book that used the method I'm used to, I wouldn't have to go through this. I'm not really sure. I can't tell you why they seem to be going in this direction. They want to do it this way. My way, it's not really my way, but the other way would say the first class would be like this. To me, that just makes so much more sense. And if you like that way, you can do it this way. If you don't really like that way, some people don't like to be reminded of algebra and the inequalities. Right? That almost makes me want to cry, but it's up to you, because you can do it the book way, or you can do it this way. If you do it this way, boundaries and limits are the same. My scale here for my histogram would be 0. Then I could actually just use 0, 8, 9, 18, so forth. Over here, you've got to take account that there's a gap between these two. And of course, there has to be. If there's a 9 there, where the hell would 9 go? Both places? Neither one? I don't know. So I've got to do this. And if you want to, you could start, if you really want to, but that gets a little freaky. I would just say put the -0.5 there, just so your bar can live on its own. Up to what? 8.5, 17.5, and now just keep going up by 9, 26.5, until the last class, of course. Holy crap, they're getting really wide. Oh well. And then finally, I've got to make that last one 45.5 so I can suck that last one in there. How we doing? Is that right? Okay, maybe. All right, and then now I really just asked for a frequency histogram, but I wanted a relative frequency distribution. So how do I get the relative frequencies here? What is that another name for? Percentage. I love it. So there's 12 people in here out of 39 people, not 45. 45 was the highest number of hours somebody worked. How many people are there? 39. So 12 out of 39?
30.8.
30.8? 6 out of 39?
15.4.
Who? 15.4?
30.8.
5,
12.8.
and 4.
10.3.
And if you add all these up, it should come out close to,
100.1.
yeah, it comes out to 100.1 just because we rounded. So that's allowed. Yes, sir. Yes, ma'am.
So I got confused here because in the book it's saying that one is percentage and then one is relative. There's relative and then percentage.
Well, there isn't. There's. I can write the decimal. I can write it as a decimal, or I can write it as a percentage. And I'm kind of happy you're saying that because what I'll see a lot of times is people will write this for the first class. What's wrong with that for the first class there?
A lot.
It's 0.308. If I want that as a percentage, it would be
30.8.
30.8%. You don't do both. 0.308% is a very small amount, less than 1%. That's not what we're trying to say. It's one of the higher amounts. So it should be 30.8%. So don't make a big deal. It's just either as a decimal or as a percentage. And of course, percentages are just easier to look at. So we normally just go ahead and take it to a percentage. Yes, ma'am.
Can the percentage be rounded up? So for the first one, I would get 31%. And
Yeah,
do
you
it
can do
like
that. You can do that. Especially because we're not going to be able to draw it all that precisely.
Okay.
Especially not me. Okay, as you'll find out more and more. You really probably should take it out to one place, though, because if you take it out to a whole number, it might round off a lot further away from 100. Yeah. Now, this scale, then, I want frequency, not relative frequency. So how far up do I want to be able to take that scale? 12. It just says to go up to 12. So maybe I can do it 2, 4, 6, 8, 10, 12. Please, dear God, you don't always have to go by ones. Right? I have people going up to 30 and it's like, 1, 2, 3, 4, 5, 6, 7, 8. No. Right? It's like the person in that horror movie in the corner of the room. Don't do that. It's a little freaky. How tall should the bar here be? Yeah, it should go up to 12. Now it's the easy part. Should be the easy part. You just fill in the rectangles, make them as tall as this says to. This says to go up to 12. Then 6. 12 again. No gaps here. 5. 4. So that's kind of nifty. I mean, that's a really quick visual of at least 39 people in here. Right? And I'm curious about the rest of you guys, if there's anything that puts you together as far as how much you work. Maybe the rest of you are people that work a lot, and that's why you didn't have time to do this survey. Or not. We'll see. But it's sort of what I expect. I expect a lot of people to not work, not have to work, not work much, whatever. And then I expect, in community college especially, I expect to see another bar higher up. And I expect it to go pretty far up normally. Not a lot of people up here, but there are people up here. During my college, I was up here working 3 jobs, paying by the way. So I understand that. And I also understand this would be a really nice place to be. Right? Sometimes it's not. You want more hours. I understand that. But it's kind of nifty. For you guys especially, you're actually seeing true data that represents this class. And I can try to find out what it looks like compared to regular Grossmont college students and see how far off we are. In later chapters, we can actually get a number that tells us how close we are to the population of Grossmont. That's going to happen later. One last thing. Always label both of the axes. So put relative frequency or frequency here. What would I put down there? Good. Number of hours worked? By math 160 students. You don't have to get hyper detailed there, but don't just put classes. Put something that represents physically what's going on. Yes, ma'am.
You might have said it earlier, why is that not a percentage going up the frequency side? Why didn't we do relative
Oh,
frequency?
what I asked you to create is just a frequency histogram.
Okay,
So
okay.
use the frequency numbers. If I say relative frequency, you
Then
have to
that's
do
when we use it.
that. So be real careful. I mean, I'm not going to take a ton of points on it, but you will lose something if I ask for a 1 and you give me the other one. Yeah. Okay. Cool. So just to give you an example, because obviously the numbers are not always going to be this nice. These numbers are very nice. These numbers are whole numbers. Those are nice. So what if your data had decimals in it? So for example, your data looked like 7.81, 2.96. Then your classes might look like this. Your classes might look like 2.50 to 2.99, so forth. You with me? Okay. So then what would your limits look like? What would the limit here be? I love it. So well, I understand what you mean. So look at this like 250. Take the decimal out for a second. And in fact, in a lot of mathematics, this works. Just to take it out and put it back in. That's 250. What's halfway below that? 249.5. So put 2495 and then just put the decimal back where it's supposed to be. So don't make a big deal. There will be some in the book that go that far out when you're doing your homework. Don't make that big of a deal out of it. This is 299. So it should go to 299.5. Put the decimal back where it goes. Not a big deal for those limits. And if you want to do it with the inequality, you don't have to worry about that damn thing at all. Now there will be a couple of problems where they give you one that's already set up. You have to understand what limits and boundaries are, the differences. But when you go to set up your own histogram, you don't have to do it this way. You could do it 2.5 x to 3, 3x to 3.5. So that would accomplish the same thing this does, just a little easier. Okay, so totally up to you which way you want to do it. All right. So any other questions on histograms? This one.
For the class, it would also be 5.
Anywhere from 5 to 10 for this class. In real life, it could be anywhere from 5 to, who knows, especially if the sample's really huge. But for this class, we're going to see anywhere from 5 to at most 10. Cool. In the book, they tell you, they actually kind of set it up so you don't have to guess yourself how many classes to use. On a quiz or a test, I'm going to ask you, come up with your own number of classes and go from there. Cool. So don't, be real careful. On a test, when I say find your class width, don't say, I'm going to use 10 because it looks like it's going to be good. No. Beyond just bad grammar there. That was mostly my fault. You have to show me that work. You have to show me this math work to back up what your width is. Don't just say, it looks like it's going to work. No. It's got to be this kind of thing to show me. How's that? Is that all right? So histograms, there's only a couple little details that get a little freaky. You know, the decimals are here and the limits and how that relates and the boundaries. But overall, this is not difficult. I'm hoping. Yes, ma'am.
You already told us, but can you explain how you got the 5 with the 45 minus 0?
Here?
Yes.
Okay, cool. So these were given to me. That's the lowest data point, and that's the highest data point. So that's what's called the range of the data. And then I want to divide by how many classes I want to use, because that'll tell me how wide each one has to be to fit, to cover it. So I was using that wall, I think, when we were talking about trying to panel that wall in wood, just because I'm bored. So then I see how wide is that wall, and how many panels do I want to use. If I divide those two, it tells me how wide each panel has to be to cover it. Right. If any of you guys do carpentry at all, at some point you have to do that kind of calculation to figure out, do I have enough stuff to cover this thing? Okay. Is that cool? In general, if this comes out to be, if this would have come out to be 9.2, what width would you use? 10. I love it. You always round up. All right, so if it comes out to anything, not a whole number, you just round up to the next whole number. Dear God, if it comes out to be 3.24, don't use 3.24. Can you imagine trying to set up 0 to 3.23, 3.24? Don't do that to yourself. Just round up to the next whole number. Okay.
So it would be 4. I'm just checking.
Oh, yeah, you're right. If I get 3.24 there, use a class width of 4. Cool. All right. So now what I'm going to do is we're going to try to finish out chapter 2. And maybe do a little preview of chapter 3. And that'll be it. Oh yeah, you're good. All right, guys, everybody's got this here, right? If I were to take out, just make a point out of this before I leave this section. If I were to take out all the zeros, if I were to say, let me just look at the people that work, I don't think any of the zeros are those that have a job. I don't think you go there and just kind of, I'm here, but I'm going to go away. So if I took out everybody that had a 0, I think there were 10 zeros, remember. So this would be a 2 then. You with me? So this would actually look like this. Don't change your picture. Now, can anybody tell me that one change? Good, I love it. That would be roughly normal. This is what we call, this is now a roughly normal distribution. Distribution. It's one of those words that make you sound drunk. So the book talks about like loosely normal or strictly normal. This would actually, by the book standards, would be strictly normal, because the thing about being a normal distribution, it's got to start low, go high, and then come back low. To make this a big point right now, a large deal in statistics is knowing when something is normal enough to use certain things. If I have a normal distribution, we actually end up knowing a lot about it. So once we get to chapter 6, you guys are going to know a lot about normal distributions. If it's not normal, I don't know much shit about it. So I want to know, is it normal enough to do all this stuff that I know, or is it not normal enough and I got to do some freaky stuff to it? So right now we have a very loose definition. Start low, go high, go low again. Right? That is really loose. We're going to firm that up once chapter 6 gets here. But for right now, if they say it looks normal, if it doesn't look normal, that's all you look for. The way it was to begin with, it was definitely not normal. Cool. All right. So now, chapter 2 is all about representing your data. So this is a very detailed kind of look at it, but it was still a pretty quick analysis. I'm glad I'm not overly OCD about this one. All right. Histograms are relatively quick ways to get a visualization. There's actually quicker ways to get a visualization of the data, and that's what section 2.4 is all about. And I want to be very specific. There are a lot of graphs in section 2.4 that we're not going to talk about. I haven't assigned any homework about them because they're just not used very often. And there are, of course, graphs that they don't even cover in this section yet that might come up in a later stats class. But these are some of the more basic, quick graphs to make. So section 2.4. Quick graphical methods or organizational methods. Really bad for you guys trying to read what I write. So one of the first ones, and some of these names kind of give away what they do. This one's definitely a big one for that. One of the first ones, actually, let me do it a little out of order here. Let me do the same. Dot plot. So a dot plot is exactly that. You plot a bunch of dots. And what it wants to do is to show you where your data is clustering in two different ways. So let me show you, let's come up with a quick list of data here. And actually we could do sort of like a little subgroup of what we just did. So this is sort of a smaller group of people and how many hours they work a week. So all I have to do for a dot plot, and you want to be really careful, anytime you're making a graph, you want your scale to be consistent. What does that mean? What does it mean for a scale to not be consistent? What does that consistent mean?
Unequal.
Unequal
when you're like not in your classes, but times of
Yeah, the spaces between have to be the same. So if I go to try to plot these points, I can't go 0, 5, 10, 30. And this is a really quick way to make your science teacher cry, because you do a lot of graphing in science classes normally. If your scales are not consistent, you're finding these new laws of nature. It's a straight line. No, it should be a curve. Your scale is freaky, that's why. All right, so don't fit your numbers to match your data. Make your scale so that everywhere has a place to go. So if I want to do a scale of 5, that'll take me a little while, but that's all right. 15, 20, 25, 30, 35, 40, 45. So now everybody has a place to go. And here's the thing about dot plots. You put a dot on the number, and then you put another one above that if it repeats. So I would put it on 0, it would be 1, 2, 3 dots. On 5, there's a couple. On 10, there's 1. On 30, there's 3. And on 45, there's 1. And don't cheat. Don't put a dot above the little tick mark. That makes it look artificially tall. And you'll see what I mean here in a second. The tallness of it is sort of related to the tallness of the rectangles in the same kind of way. So this gives me a really quick feel for, there seems to be a lot here and a lot there. So there must be something about those two locations. Now my sample is damn small as hell. But this is the idea of creating a dot plot. How you guys doing, all right? That should hopefully be pretty simple. So whatever data they give you, you make sure it's got a consistent scale, you make sure that they all have a place to go, and then you start putting dots representing each data point. If one repeats, you put a dot over that other one. Should not be difficult. So if I see a dot plot, it looks like this. What would you say about that data?
roughly normal distribution.
I love it. It's got a roughly normal distribution. I love it. So there it pops its head up again. So that's a very quick visualization of the data. It's a lot easier than a histogram. Right? But the larger my data set gets, the less I want to really sit there and draw dots all day. I'd rather make bars, histogram. This is nice for a smaller set of data. Okay. So that shouldn't be too taxing, I'm hoping. So don't make too big of a deal out of that. It's nothing major. The next one is a little more interesting. It's called a stem and leaf plot, or just the book calls it a stem plot. I call it a stem and leaf plot. This does two things. It's a quick way to organize, to sort your data, and it's a quick way to get a visual of your data. So it's sort of the same thing as a histogram. Why not? Well, let's see. Let me make up some new data here. That's fine. Well, that's horrible, Jeff. These things happen. So here's how a stem and leaf plot works. Whenever you have these numbers. And once I start to explain it, you'll understand it's not going to work for every data set. The data set has to have certain characteristics. So here, there's definitely digits I would call the stems, and other digits I would call the leaves. There are these repeated digits, and then they have like different second digits. So obviously the 1 would be a stem, 2, 3, and the 1 has leaves coming off of it. It's got a 2 coming off of it. It's got an 8 coming off of it. We're not going to make a little tree. Don't freak out. We're going to make stems would be 1, 2, 3. My stems. 4, 5. And then the leaves coming off of there, you would put 2, 8. How we doing? That's all there's to it. 2 has a 9. 3 has a 4 and a 5. 4 has an 8 and an 8. 5 has a 0, 1, 4, 7. Now there's one little thing, yes?
Do they have any decimal?
No, they don't. I love it. Right now, if you didn't know what the data was, and I just showed you this, you wouldn't know if this meant 12. This might even mean 1200. This might mean 100 or 1002. You've got to give me a key. The book does not say this. But listen to me. If you don't put a key for me on a test or a quiz, you lose some points for that. So the key would look like this. There you go. And now you've set up for the whole thing what it means. Please, dear God. I had one student do that for every single one. That kind of defeats the purpose. You only need one representative example, and then I can kind of follow it for everything else. All right, so that bar basically means the decimal point. Now if you do this, is everybody cool so far? That's really easy. This would look the same way then if this would have been 12, 18, 29. My key would have just not had a decimal point in it. No big deal. Okay. So now if you do this and you just look this way, what does that look like now? Oh, it looks like the thing you just drew sideways, Jeff. What the hell? Well, if you do that, what does it look like? Bars. It looks like a histogram, right? So that would be the most occurring thing and so forth. You could see if it was low, high, low, you could say it looks normal. So any visual way you can represent your data, you should probably have a way to tell if it's normal or not. Does it start low, go high, go low again? That kind of thing. Here, this definitely does not. This seems to be heavy on this side. Okay. Yes,
Do you have to list in an order?
No, and as I was writing them, I'm like, I should have put it up there, not in order. If they weren't in order, as I write these down, I could put them in order, and then I've got my whole data set in order. I don't have to put them in the calculator. It's especially good for like a small list like this. Why waste time putting these all in the calculator when you just get them in order real quick like this? What sucks when you're doing this and you start crossing them off, everybody that does it that way pretty much misses one somewhere. And then everything else after that is not quite right. Yeah. I give partial credit, so don't freak out. As long as you show me your work, if you make one mistake on part A that affects the rest of the problem, I just grade the rest of the problem based on do you know the concept. They give you points off on A, everything else you can get fine. Does that make sense? Cool. So I had teachers that did not do that, and that sucks. All right, is that all right? Stem and leaf plot. Yeah, don't. This should be easy. Just don't get used to it being quite this easy. We're coming up to the more difficult stuff here soon. One last thing I want to say in this section. Something called a scatter plot. So one of my favorite examples for this kind of thing actually also deals with Chapter 10. Chapter 10 is going to come back to this again. And it's actually part of the reason I got this job, because I had to videotape me teaching and send it in for the application for this job. And they said they liked the fact that I talked about beer. So that kind of, I felt, I shouldn't probably tell you that, but, oh, that's why I teach you. So if I had data points that represented the number of beers I had last night versus the grade on my 7 a.m. exam, I'd expect there might be some kind of an effect. Right? And Chapter 10 deals with this kind of thing, this idea of a correlation. Does it look like there's a relationship between these two variables? And I can't say that one causes the other. But obviously here it would be somebody trying to say the number of beers you have would cause you to get a lower grade, possibly. Right. All depends on how you can hold it. So here I might have somebody that had no beers and they made 88. And somebody else had 4 beers and they made 7. And then you got the guy that had 1 beer but he doesn't know shit anyway. And then you got the other one that's just drinks an insane amount of beer.
And it's really small.
And you know, doesn't suffer any hangover or anything. It's nice for him. So all a scatter plot is they're not going to give it to you as points, but you realize that's what they are. They give you 2 sets of data that kind of go together. Therefore, 0 goes with 88, 4 goes with 70. So they kind of naturally line themselves up into points, and that's how you plot them. You just plot them on an XY plot. Not a big deal. That's just what a scatter plot is. So here this would be 0 would be 88, 10, 20, 30, 40, 50, 60, 70, 80, 90. So 0, 88. 4 would be 70. Oh, I should have probably. That's always the most exciting part. 470, and so forth. I mean, that's pretty much all I should have to do. So if they're going to ask you, I think you got 2 scatter plot problems, or I do want you to do it by hand. When we get to chapter 10, I'll show you how to do it in the calculator. But for right now, it's just plotting XY points. And then they'll ask you, do you see a trend? Do you see some kind of a pattern to your data? Right, so if I did this for beers and grades and I saw this, and then I got my outliers. There's sort of a trend here for most people, right? This is the guy that can drink a hell of a lot and still makes a high grade. This is one that you don't know anything, so it doesn't matter. Go ahead. Drink up, but he didn't drink up for some reason. So these 2 are sort of outliers, but the overall trend is a downward trend, possibly. I wouldn't think it'd be that strong, but maybe it would.
Depends how early you drink them, too.
It depends totally on your own characteristics related to beer consumption. So, and I'm not saying to try to do this experiment. I'm not condoning that in any way.
Just your friend.
Yeah. So, is that cool? I mean, so that section really, let it be easy. That section should be nice. And the same thing for the next section, actually. The next section, once we talk about 2, 2, 2, 3, 2, 4, setting up your data, showing people visually what it is you found, all this kind of business. 2.5 then says, okay, here's all the ways that people can mislead other people and give stats a bad name. And I already showed you one example. I showed you this example the first day, I can't remember, where they had like income for men and women. You had men here, you had women there, and you're like, oh my God. But the scale doesn't start at 0. So it misrepresents the heights of those bars. So if you were to start the scale at 0, that gap would be not so pronounced. So it still might be a concern. In fact, this is what really pisses me off. If there's something you really feel strongly about, and there's somebody out there giving information, and you see them doing a shitty thing like this, you're like, the issue in itself is important. You don't have to do this. Then people just kind of dismiss it. They say, well, there you go. Somebody lied. The whole thing's a sham. And we're going to drop the whole thing. And I'm like, no, you don't have to do that shit. It's bad enough on its own. Why do this kind of thing? But people do this kind of thing all the time, just to, especially people that are really passionate about something, and it might be true. They do this, and nobody listens to them ever again. Like, you're the guy who did that. Screw you. Then you're screwed. But you see this kind of thing a lot, more than you realize. Circle graphs are shown without the right proportion, all this kind of stuff. It's silly. Okay. So all this section really is about, there will be a couple that say, tell me what's wrong with this, and then they'll follow it up with, redraw it so that it's correct. One other thing that happens a lot with these kind of things is they'll use like, let's use something that's a little easier mathematically, a little cube. So we'll say this is the college president's income a few years ago, and now it's Doubled. Wow. So, what's wrong with doubling a three-dimensional figure's length, width, and height? What happens to the actual, more than that? If this is 1, 1, 1, what's the volume here? 1. If this is now 2, 2, 2, what's the volume here? 8. So you're actually saying it's 8. You're representing it as 8 times as big. So if you use a 3D object to represent something linear like income, there aren't 3 dimensions to income. It's a number. It's 1 dimension. That's misleading. You see all the little oil barrels representing the oil production or usage of countries and stuff. You see it all the time. We don't even realize it's possibly misleading. But something like this would be misleading. You should probably represent it like that. Maybe with a better scale. So 2.5 itself should not be that big of a deal. If I'm wrong and it is giving you trouble, don't hesitate. Come see me. Right, there might be a couple that kind of sound weird. A little preview of where we're going. Chapter 1 and 2 for me sometimes, I just want to kind of get through it and show you everything, because chapter 3 is where we really sink our teeth into data. Chapter 3 is where we're going to start talking about mean, median, mode, something called standard deviation, z-scores. We're going to really just jump into the real basic math of statistics. How do you work with numbers, and what does it tell you when you get this stuff out? What's the difference between mean, median, mode, and all this kind of crap? Okay. So that's what chapter 3 is going to be all about. Cool. Get out a little early. Any questions over stuff? All right. So, I'll see you guys Wednesday. Oh! Of course, if anybody ever watched Columbo, this is Columbo's One More Thing. Wednesday, there will be a quiz on chapter 1.
Does that mean all
No, that's just what
Yeah, and again, the homework thing, we finished up chapter 1 last Wednesday, so officially it is kind of due this Wednesday, but you always have until the day of the test if you need it. So if you're done with it on Wednesday, you're on track. If you're close to done on Wednesday, you're on track. If you haven't even started it by Wednesday, you're behind. Good seeing you. Please give me back my calculators. Thank you.
Can you turn in homework on the day of the test, or so you can't do this? Can we turn it early?
You can definitely turn it in early.